Linear programming is a very practical application of systems of equations and systems of inequalities. There's quite a bit of vocabulary. I have these in a list for you. Go ahead and write them down. The constraint is the restrictions on the variables of the objective function in a linear program. Usually constraints, you'll have 3 or 4 or more inequalities you have to solve. The feasible region is the region bound by the constraints. Linear programming is the method for finding the maximum or minimum values given the constraints. And the objective function is a model of the quantity you want to make as large or as small as possible. Now usually we're dealing with profit, and of course we're going to maximize profit or cost, and usually we're going to want to minimize cost. If there is a maximum or minimum, then it will occur at one of the vertices of your feasible region. So remember, your feasible region is going to be defined by your constraint equations. So you're going to need to graph your constraint equations, find your feasible region, and then evaluate your objective function at each vertice. So let's look at this problem here. Suppose profit is 6x plus 2y. If we have a maximum, it's going to occur at one of these 4 vertices. So let's try out each vertice. At 0, 4, P is 6 times 0 plus 2 times 4. So that's 0. So this is 8. At 2, 4, P is 6 times 2 plus 2 times 4. So this is 12 plus 8, or 20. At 6, 0, P is 6 times 6 plus 2 times 0. So that's 0. So this is 36. And then at 0, 0, P is 6 times 0 plus 2 times 0, and both of these go to 0, so this is 0. So let me make a chart. Let me label it A, B, C, D, and then let me list the profits. I'm going to assume P stands for profit. So at A, at 0, 0 was 0. At B, 6, 0, it was 36. At C, which is 2, 4, 20. And at D, 8. So if there's a maximum profit, it will occur at B, at 6, 0. Let's find the minimum for 4x plus y on this problem. Now, if you look at this, this is actually an unbounded region. So we're going to need to look at the endpoints. A is 2, 1. That's kind of hard to see. B is 3, 0. And C is 5, 0. So at A, which is 2, 1, P is 4 times 2 plus 1, which is 8 plus 1, or 9. At B, which is 3, 0, P is 4 times 3 plus 0, so this is 12. And then at C, which is 0, 5, P is 4 times 0 plus 5, so that's 0, so this is 5. So the minimum will occur at C, at 0, 5, given these constraints.